Hello students, welcome to engineering geology classes. We will start with module 3, that is structural geology and rock mechanics. So there are two branches we are going to discuss in this module 3. So the structural geology includes different structures which are formed on the earth, like the folded rocks we see, the faults, the joints, unconformity, all these structures and how they are formed and how they are important from engineering point of view. That is a very important concept for a civil engineer. So in this structural geology we are going to discuss what is mean by outcrop, dip and strike, folds, faults, joints, unconformities and their influence on the engineering projects like dam, tunnel. So how, if suppose if the rock is folded, what effects it will have when you go for construction of a dam or a tunnel. So the different types of folds, different types of faults, joints, that we are going to discuss in the structural geology. Then it also includes the slope treatment, how the slope in a hilly region, how the slope should be treated, then what are the ground improvement techniques, then recognition of all these folds, faults, how to recognize them in the field when you go to the field, and if you find any type of this structure, how to recognize that structure. Then these all and the types and classification of all that structures we are going to discuss in the structural geology. Then in rock mechanics we are going to discuss rock mechanics. Again is a branch of geology which deals with how the behavior of rock under pressure. So when you apply pressure, how the rock will behave to that pressure. So here we are going to determine RQD, that is the rock quality determination, rock structure rating, that is RSR. Then this comes in rock mechanics. Then even we are going to discuss how the site is selected for the construction of dam, tunnel. Okay, what is the site selection? So geological site characterization for dam foundation and the rock foundation treatment for dams and reservoirs, heavy structures by grouting and rock reinforcement. So the dam, when you go for construction of a dam, based on the type of rock, the structure which is exhibited by the rock, based on that you have to provide a proper foundation for that rock. So how it should be provided, that we are going to discuss in this module. Then at the end we are going to discuss about the tunnels. So you might have seen many type of tunnels when you go to Dudhsagar, which is very near, right? So when you go to Dudhsagar or Konkan railway, if you have traveled, you will come across many tunnels. So tunnels are the passage or underground passage which is constructed when the two places are separated by an obstacle like a hill or a water body. So that is a tunnel. So how these tunnels should be constructed, what are the basic terminologies which are associated with the tunnel, and what is the application, how to select a proper site for the tunnel, that we are going to discuss in this. And then the last concept is coastline and their engineering consideration. So we can deal with coastline also, like along the coast we need to construct the harbors, docks, jetties. All these are again come under the civil engineering, right? And you must know, or you must be aware, that what are the different processes or the structures which are happening on the coastal areas, right? So in the previous class we had discussed about this the coastal landforms we have seen. So the coastal phenomena, right, because we deal with the saline water, what type of material we should use, okay, and all, the how your structure will be resisting the action of waves, all that we are going to discuss in this module. Okay, so this includes two branches of geology, that is structural geology and the rock mechanics. So we will start with the structural geology first. So before starting the folds, faults, you must know what is the reason behind development of such type of structures in the rock. So we will first understand what are the different forces acting on the rock, what is mean by stress and strain. So that is again a part of rock mechanics. So these two branches are interconnected, so it is clubbed in one module. So let us understand first what is mean by the stress and strain. Stress and strain. So what is stress? Stress is a force which is exerted against an object. So what is a stress? Stress is a force, and how it is exerted? It is exerted against the object which is undergoing changes. Okay, so the tectonic forces, they exert different types of stresses on the rocks in different geological environment. And strain is what? Strain is the deformation which is produced by the stress, right? Strain is the result. Suppose you have a rock in your hand and you are applying the force on it, that is a stress. And after applying rock, how this body behaves? Either it will break down, right? It will break down into pieces. So that effect, okay, that is called as the strain. So strain is the deformation which is produced by the stress. So we'll understand first the different types of forces acting on the rock. So the first type of stress which is acting is called as the confining stress, or it is called as confining pressure. So confining stress or confining pressure, it occurs when the rock or the sediment that is buried inside the water, okay, and the confining pressure, what it does, it just compresses the rock, but it does not distort them, okay, because the compressive force acts equally in all direction. Like you can imagine a fish in the water, how it floats, because the confining pressure, because of that confining pressure, it can swim easily into the water because it acts from all the directions equally. As you can see in this image, okay, on this body, the stress is acting equally from all the sides. So that is called as confining stress or confining pressure. So it is equal from all the sides, and it just reduces the volume without any deformation. So deformation is not caused, only the reduction in the volume take place in case of confining pressure. Then this also contributes to metamorphism also during the deep burial of the sedimentary rocks. Then so this is when the directed stress acts more strongly in one direction, then you can see the metamorphic effect in the rock. Then the tectonic forces which are happening in and around us, they I had told you there are three types of forces. Like one is convergent, other one is divergent, and one more is just transform. Boundaries are there, and those are shaping the earth, okay. They are the main agents which are responsible for the changes which are taking place on the earth. So there are three main tectonic forces or processes that create three different types of directed stress. So first one is the compressive stress, okay, that is this type. Okay, so what is that compressive stress? That is common in convergent plate boundaries. So wherever there are convergent plate boundaries, so the tectonic compression and deforms rock and shortens the distance between the 2 points. So what happens, you can see in the image wherein the stress is acting towards each other, right? So when the two plates converge, then what happens, the rock starts crumpling. So crumpling, the rock crumples, and just you can just imagine when there is a head collision of two cars, what will happen, it crumples, right, on collision. So same happens here also. It shortens the distance between the 2 points. So that happens in case of compressive stress. Then one more is extensional stress, or it is called as tensional stress, which pulls apart. Okay, it is moving away from each other, that is called as extensional stress. So what happens because of the extensional stress, it pulls the rocks apart, and it is opposite of the tectonic compression, right? In compression what happens, it acts towards each other, but in a extensional stress it moves away from each other. So rock at divergent plate boundaries, they stretch or they pull apart, and because of that they are subjected to extensional stress. So that results into faulting of the rock. So this is called as folding, which is because of the compression, and this is called as the faulting of the rock, that is because of the tensional forces or stresses acting on the rock. Then the last one is shear stress, that acts in parallel but in opposite direction, that is called as the shear stress. It acts in a parallel but opposite direction. So shearing, what it does, it deforms the rock by causing one part of the rock mass to slide past one another, and as you see in transform fault or transform plate boundaries, there is just a movement or sliding of the rocks in opposite direction takes place. So these are the different types of stresses which are acting on the rock. And what is a strain? The effect what we see on the rock, okay, like here in compression the rocks get folded, in extensional forces or tensional forces the rocks undergo faulting. Okay, so that type of deformation is called as the strain. So strain is a deformation that is produced by the stress. So suppose a rock is responds to tectonical stress by elastic deformation or plastic deformation or brittle. So these are the different stages of deformation. You can see here now the stages of deformation. So there are three stages of deformation. One is elastic deformation, ductile, and the brittle deformation. So these are the stages of deformation when the rock is subjected to stress. Okay, it passes through these three stages. Okay, so first let us understand what is mean by elastic deformation. So here the strain is reversible. In elastic, you can imagine a rubber. Okay, what happens when you stretch and what happens when you release the stress. Okay, so if a deformed body, it recovers its original shape after the stress is removed or reduced, that is called as the elastic deformation. The best example is rubber. Okay, to understand the behavior, even the rock behaves in a elastic manner. So rock can behave in elastic way at very low stress. So once the stress exceeds, the elastic limit of the rock will exceed and the rock will deform permanently, but when the stress are less, okay, it behaves in a elastic manner also. So that is called as the elastic deformation, wherein the strain is reversible like a rubber. Then what is mean by ductile? So ductile, wherein the strain is irreversible. The strain is irreversible. Means what? It will not come back to its original shape. It remains in the deformed shape. So rock that behaves in a ductile manner or a plastic manner, that will bend. When you apply stress, it will bend, but it does not return to its original shape when you relax the stress or when you release the stress. So that is the difference between elastic and ductile. So under high pressure and temperature, like during metamorphism, what happens? The rock behaves in a ductile manner. So ductile behavior results in what? The folding of the rock or the bending of the rock, as you can see in this image, right? The rocks, they undergo folding because of the ductile behavior of the rock. So because the stresses are acting on the rock starts folding like this, okay, but when you remove the stress, it will not come back to again flat, okay, it remains in the bent form. That is called as the ductile deformation. It is not breaking, it is just bending. So that is a ductile. But in brittle, what happens? Here also the strain is irreversible, wherein the material breaks. Okay, here the material breaks. Like here you can see the fault. A rock will exhibit brittle behavior, that will break or it will form fractures, and when the rock the stress or the rock exceeds its elastic limit, then it will undergo breaking. So the rocks typically exhibit the brittle behavior at or near the earth's surface, where the pressure and temperature are low. So faults, formation of faults or the joints are the cracks in the rock. So they are the example of brittle deformation, which is the structure which is formed by the brittle deformation. So these are the different types of deformations: elastic, ductile and brittle. Then we'll see what are the factors that control the behavior of the rock. Okay, the first one is nature of the material. So like suppose the three type of deformation you have seen. So you can just imagine a quartz crystal. Okay, a crystal of quartz is a mineral. Okay, and you can take a gold, okay, and you can take a rubber ball. So if you take these three different materials, the nature of material matters, okay, in the behavior of the rock. Suppose if you have taken a quartz crystal, okay, what will happen? If you strike the two quartz, okay, or quartz with a hammer, what will happen? It will break, it shatters, okay, it will break into pieces. That is what? It fails by brittle deformation, it will break. But if you strike a gold against the hammer, then what will happen? The gold will behave, it starts becoming flat when you hammer a gold. Okay, a nugget of gold, if you hammer, it deforms in a plastic manner, right? It starts flattening. Okay, that is what the plastic deformation. It flattens and it remains flat. It will not come back to again original shape. So and at the end, if you hit the rubber ball, what will happen? It deforms elastically and it rebounds immediately. And if you hit by a hammer, the hammer will fly back. Okay, so that is how the nature of the material, so it affects. So initially all the rock, they reacts to the stress by deforming elastically, and when the elastic limit is reached, the rock will start behaving differently with the temperature, pressure, okay, and the pressure acting on the rocks. So that is, for example, granite and quartzite, they tend to behave in a brittle manner, whereas the other rock like shale, limestone, marble, they have a greater tendency to deform in a plastic manner. So that is why the behavior of rock is very, very important. So this depends upon the nature of material. Next factor is temperature. So higher the temperature, the greater is the tendency of a rock to behave in a plastic manner. Suppose the best example to understand the effect of temperature is if you want to bend an iron bar. So at room temperature it is very difficult to bend that bar, but if the same bar, if you heat the bar, okay, in a forge, and that becomes plastic, right? It bends plastic, and then you can bend it very easily. So that is what the behavior of the material, how the temperature affects the behavior of the material. Then the next factor is the pressure. So high confining pressure, that again favors the plastic behavior of the rock. So during burial of the sediments, what happens? Both the temperature and pressure goes on increasing, and both these factors, they promote the plastic type of deformation. So if the rocks are deeply buried, the rock have a great tendency to bend or flow than the shallow rocks. So that is how the pressure affects the rock. Then the last and important factor is the time. The stress applied over a longer time rather than suddenly, right? That again favors the plastic behavior of the rock. So rapidly if you apply stress, then it will cause brittle deformation. If it is applied over a long time, okay, rather than suddenly, if it is applied slowly, then it behaves in a plastic manner, the rock. And if you apply suddenly, if suddenly some stress is acting on the rock, then it causes the brittle deformation or brittle fracture. So this is how the different factors control the behavior of the rock. Then the next concept to understand is the outcrop. So let us discuss what is mean by outcrop. So outcrop, we can see the exposure of the rock on the earth's surface, right? The rocks are exposed in the form of hills, valleys, right? Wherever there are hills, valleys, the rocks are exposed at the surface of the earth. So what is an outcrop? So outcrop is defined as the exposure of solid rock on the surface of the earth. So whenever a rock is exposed on the earth's surface, we call it as a outcrop. So here you can see in the figure, okay, you can see the outcrops, that is the exposure of the rocks. Here you can see when the outcrop lines or the trend of the rocks, they are parallel to the contour lines. So first let us discuss what are the contour lines. So contour lines are the imaginary lines or which joins the heights or elevation, okay, with the equal elevation. Suppose there is a hill and this is a contour line which is represented by a dotted line. So suppose the height at this point is suppose 800 meters, okay, and at this line the height is 700 meters. So what it shows? The contour lines are the imaginary lines. So on the ground actually you cannot see the lines, right? It's just an imaginary line which represents the elevation of that particular area. So along that line, throughout its length, the height remains the same, that is 800 meter, and all along the length of this line the height remains the 700 meters. So that shows that is a contour line. It is an imaginary line which joins the heights of equal elevation, right? So that is a contour line. So again, the contour line are always numbered. When you see a topo sheet or a map, there you can see the contour lines will be shown on that map. So in the lab you can see in the next sem the topo sheets, okay. So there you can see the contour lines also. So those contour lines, suppose they are rounded, okay, and the contour lines are rounded, and suppose the highest elevation is at the center and the values are decreasing away from the center, then you can imagine that is a hill, that will be a hill. And suppose if it is reverse, if the lowest contour is at the center and the contour values are increasing, okay, lowest is at the center and the values are increasing away from center, then again it shows a valley, because lowest elevation at the center, like this, okay, lowest elevation, then the height is increasing away from the center, so this shows a valley. And in case of a hill, what happens? The highest elevation will be at the center and the values goes on decreasing away from the center, and here increasing away from the center. So this is how the contour line help us to know whether it is a hill or a valley. Then even it will tell us the slope, like whether it is a steep slope or the gentle slope, that is understood by the spacing of the contours. So if the contour lines are very closely spaced, then this shows the steep slope, okay. And if the contours are at a distance, they are very far from each other like this, then this shows a gentle slope. This is a gentle slope and this is a steep slope, okay. So the spacing of the contours that also shows the slope, or the whether the slope is steep or a gentle, okay. So let us understand what is mean by the outcrop. Outcrop is the exposure of the solid rock on the earth's surface. So when the outcrop lines, so these are the rocks which are which you can call it as outcrop rocks, okay, which are exposed on the earth's surface. So when the outcrop lines they, or the trends of those beds, they are parallel to the contour line. You can see the dotted lines are the contour lines and the thick lines, they are the bedding planes, or you can see the beds, okay. So here in the first image you can see the dotted lines are contour lines, and these beds, they are running parallel to each other. So this shows the beds are horizontal. The beds are horizontal. And when these outcrop lines, okay, or the beds, they trend or they intersect the contour lines. So these are the contour lines which are horizontal, and these are the trends of the rocks or the beds which are intersecting the contour lines. So this shows the beds are dipping. Okay, the beds are dipping, means they are inclined, and here the beds are horizontal, okay. And when the outcrop lines, they are straight but they intersect the contour lines exactly vertical, okay, then this shows the beds are vertical. So when the outcrop lines are parallel to the beds, they are conformable and they have the same amount of dip, okay. So just to next concept is to understand what is mean by dipping, dip and strike. That is a very important concept, but before that you just understand what is a outcrop. And there are two types of outcrops. One is outlier and other one is inlier. So let us discuss what is mean by outlier. So here in this image you can see there are the beds which is represented as A, B, C, D and E. They are the beds which are deposited one above the other, and these beds have folded, right? These are folded like this, okay, and this is the outcrop. Okay, this is the outcrop or outline, you can see that is the outcrop of that. Okay, so here this is the surface, ground surface, okay, and this is the imaginary line, dotted line. So here there are 5 beds A to E. So here A is at the bottom, right? So it is a first formed bed, so obviously that bed is a older bed, and whereas E bed is at the top. Okay, so top it is formed after the formation of B, C, D, so it is a younger bed. So older and younger bed, older will be at the bottom, younger will be at the top. Okay, now let us understand what is mean by outlier and inlier. So here in the image you can see here I have written as outlier. So what is exposed here? Which bed is exposed? The younger bed, that is at the top. So it is exposure of younger bed which is surrounded by the formation or exposure or outcrop of the older formation. So here younger bed is exposed, surrounded by the outcrop of older formation. So this results due to excessive erosion or due to faulting which is followed by erosion. So that is called as an outlier. So when the younger bed is exposed, surrounded by the outcrop of older rock, that is called as an outlier. And what is inlier? Inlier, here you can see what is exposed. The older bed is exposed on the surface. You can see, right? Here the younger bed is exposed. Here the older bed is exposed, which is surrounded by the outcrop of younger rock. So that is called as an inlier. So inlier is what? It is an outcrop of older rock which is surrounded by the outcrop of the younger rock. So that is a outlier and inlier. So inliers are typically formed by the erosion of overlying younger rocks, and when they are exposed, okay, then they undergo weathering and erosion and the underlying rocks are exposed, and that is how an inlier is exposed on the surface of the rock. So these are thus the reverse of outliers. Okay, inliers are reverse of outlier. So valley formation is a common process of erosion which gives rise to inlier. Suppose if you imagine a valley, okay, in valley what happens? This will be the oldest rock, and the rocks will be deposited like this. This portion has eroded and it has formed a valley like this. Okay, and the rocks on either side of the valley, they will remain as it is. So here the exposure of older rock which is surrounded by the exposure of younger rock, you can see that is called as an inlier. Whereas in outlier you can expect a hill. So in a hill there will be an outlier. Okay, because here in the hill what happens, the older bed remains at the bottom and younger bed is exposed. So younger bed at the top, that is called as the outlier. So these are the types of outcrops, inlier and outlier. Next is the very important concept, that is the dip and strike. This is very important concept. If you understand this, you can understand the different types of folds, faults, because they are based on this dip and strike. Okay, so let us understand what is mean by a dip first. So this dip and strike is also called as the attitude of beds. Attitude is nothing but the dip and strike. Remember, it is attitude, not altitude. Okay. So what is a dip? We'll understand first. So dip, the attitude of the bed, that is in the image you can see. Yes, so here in this image you can see there is a rock which is exposed here like this. Okay, this is a rock body, and you can see the beds are dipping in this direction. So what is mean by that dip? So dip is the angle of inclination of a bed with respect to the horizontal plane, which is an imaginary plane. This horizontal plane, you can see, this plane is an imaginary plane. The horizontal plane, that is a imaginary plane. And what is dip? This is the dip. What is that? Dip is the angle of inclination of a bed with respect to the horizontal plane. That is called as a dip. Okay, I hope you have understood what is mean by dip. So dip is the angle of inclination of a bed with respect to the horizontal plane. That is called as a dip. So dip is measured in a plane which is perpendicular to the strike of the bed. I'll tell you what is mean by strike, but before understand what is a dip. The angle of dip is expressed in degrees. Okay, so if the beds are horizontal, what will be the dip? The dip will be 0 degree. They are not inclined at all, so the dip is 0 degree. And if the beds are vertical, then the dip will be 90 degree. So the geographical direction along which the bed has a maximum slope, that is known as the direction of the dip. So this in the figure you can see the beds, they are dipping at an angle of 30 degree. So if you pour a water on the rock, it will move in this direction, right? Along the slope it will flow. So that is nothing but the dip of the bed. So these rocks, they are dipping. So here also you can see the rocks are dipping. Okay, this is on the top. This is if you take a cross section, right? So these are dipping at an angle of 30 degrees. So angle of inclination of a bed with respect to horizontal, that is called as a dip. Okay, then so this dip is if it is horizontal it is 0, if it is vertical it is 90 degree. Okay, so it is dipping 30 degree towards east. So the north line is given. So north, south, east and west. So these beds are dipping due east, 30 degree east. Then let us understand what is mean by strike, which is again a very important concept. So strike can be defined as, just see here, look at the figure, this is the strike. So how you will define a strike? Strike is defined as the direction of a line, the direction of this line. And how that line has formed? This line has formed by intersection of the bedding plane, okay, and the horizontal plane. So these two planes, okay, they intersect at this line. So this line, the direction of that line, that is called as the strike. So strike can be defined as the direction of the line which is formed by the intersection of the bedding plane and the horizontal plane. So they are intersecting along this line. Okay, so this is a bed, okay, and this is a horizontal plane. So they are intersecting at this line. Okay, so the direction of that line is called as the strike. So direction of the line along which an incline or a dipping bed it intersects a horizontal plane, that is known as the strike of the bed. So you can call it as a trend of the rock. So this is the trend of the rock. The other way of defining strike is the trend of the rock. okay, or the beds on the ground surface, that is called as the strike. So strike is always at right angle to the true dip. So the strike direction is measured by compass. Both the dip and strike can be measured with the help of a compass. There are different compasses. One which is commonly used is Brenton compass, or even the clinometer. They can be used to determine the dip and strike of the bed. So the strike is represented as, suppose here the rock is dipping at 30 degree, and this is the line, and this angle will become again 30 degree. So the direction of this line, so how you will represent the direction of this line with respect to north? So this can be written as north 30 degree east and south 30 degree west. Okay, south 30 degree west. So both the directions we have to write, north south, east west. Okay, so north 30 degree east and south 30 degree west, that is the direction of this strike. Okay, so this concept is very very important, that is dip and strike. Then next, let us see what are the different types of dips. So there are different types. So the very common is true dip and apparent dip. So true dip is what? It is always perpendicular to the strike. Suppose this in the figure you can see SS is the strike direction, then the dip direction AD, if the beds are vertical, so this dip direction AD is called as the true dip. So true dip is always perpendicular to the strike. And what is apparent dip? In the second image, this is the strike, this is the true dip, which is always 90 degree to the strike. Other than true dip, whatever the dip directions are, that those are called as the apparent dip. So they are always less than 90 degree. Then there are primary and secondary dips also. So primary dip or initial dip, it is the inclination of a strata due to original slope of the basin. Suppose the basin itself is having some slope, and on that basin the rocks have formed parallel to that. Okay, the deposition has taken place, that is the original slope of the rocks or the basin. Then that is called as the primary or initial dip. That is generally less than 35 degrees. It is generally ranges between 0 to 20 degree. Then secondary dip is what? It is the dip or the inclination that includes or that is induced in the strata after its formation or deposition due to the tectonic forces which are acting on the rock. So this dip is always it varies between 0 to 90 degree. So that is because of the tectonic forces which are acting on the rock becomes inclined, and that dip is ranging between 0 to 90 degree. That is a secondary dip. Okay, so these are the types of dips. The very important is true dip and apparent dip. So true dip is always perpendicular to the strike. Okay, and apparent dip is other than 90 degree. The other dips, they are called as the apparent dips, which is less than 90 degree. So in the next class we will start with the structures of rock, that is folds, faults, joints and unconformity. So for today's class we have discussed what is mean by stress, strain, stages of deformation, brittle, ductile, okay, and plastic behavior, okay, stress, strain, okay, and what are the factors which control the behavior of rock, okay. Then the outcrop, that is exposure of rock on the earth's surface, then we have discussed what is inlier, outlier, and then we discussed what is mean by the dip and strike, which is a very very important concept. The dip and strike is also called as the attitude of beds. So if it is asked in the exam, you have to represent with a diagram. Okay, diagram drawing is very very important for this chapter. Okay, folds, faults, also we need to draw the diagram. So here this includes your attitude of beds. Okay, thank you.